Hello everyone. Before starting the lesson, try this warm-up. Evaluate each of these expressions. Evaluate just means get the answer. For the last ones that have fractions as the base of the power, see if you can get the answer as a fraction. Pause the video and try this on your own. Just recall that an exponent tells you how many times you're multiplying the base by itself. So 2 to the exponent 4 means 2 times 2 times 2 times 2, which is 16. Here the base is minus 2. Multiply it by itself 4 times, you get 16. Here the base is 2, not minus 2. We actually end up with a negative 16 as the answer. Notice the difference between this one and this one. Here, the negative 2 has brackets around it, meaning the entire negative 2 is the base of the power. Here there's no brackets, so the base of this power is just 2. That negative sign is just what we're multiplying the entire power by. So we have a negative 16. When you have a fraction as the base, you follow the same rule. You're multiplying that base by itself 3 times. When you multiply fractions, it's numerator multiplied by numerator multiplied by numerator, and denominator multiplied by the denominator multiplied by the denominator. Or 1 to the exponent 3 is 1, 3 to the exponent 3 is 27. For this one, 7 to the exponent 2 is 49, and 8 to the exponent 2 is 64. And we can leave our answers as fractions. 49 over 64 is a fraction in lowest terms, so this is fine. This lesson is about exponent laws. We're going to simplify and evaluate expressions using the exponent laws. So I'm going to outline what these laws are that govern how you work with exponents, and then we're going to do some examples for how you can evaluate expressions using these laws without using a calculator. First, I'll just remind you of some terminology. Here I have 2 to the exponent 3. The 3 is the exponent, the 2 is the base. The whole thing is called the power. So in a power, you have a base and an exponent. So just be familiar with what these words mean: power, base, and exponent. So let's get to the exponent laws themselves. Here we are multiplying powers with the same base. The base of each power is 5, and I'm multiplying these two powers together. If I wrote this out in expanded form, I would have 5 to the exponent 2, which is 5 times 5, and I'm multiplying by 5 4 more times. 1, 2, 3, 4. Total, how many times am I multiplying the 5 by itself? 6 times. So I can take this expression and I can simplify it to a single power, 5 to the exponent 6. Now what's the shortcut? I don't want to have to write out expanded form and count all the time. Here I have a 2, here I have a 4. How do I turn a 2 and a 4 into a 6? Add them together. Here's how we can write that more formally in a general form. Here's a power multiplied by a power with the same base. We can simplify that to a single power by adding the exponents to get the new exponent. So that's the shortcut. Add the exponents if you're multiplying powers with the same base. So now you try it. Simplify to a single power. Look at each expression and just write it as a single power. One power with one base and one exponent. You don't have to answer the question, just write it as a single power. Pause the video and try it. Powers with the same base being multiplied, add the exponents. Don't worry if the base is negative. The base just remains the same. You're just adding the exponents. If you have a negative exponent, just add the exponents. 15, add negative 1, it's 14. Here, what's the base? It's not negative 2. The base of these powers is 2. That negative sign is just in front of the power. Add the exponents. So you can write it like this, or just like that. We don't really need brackets around the 2. Just as long as you don't have negative 2 in brackets. Now, what if you're dividing powers with the same base? Here's an example. If I write this out in expanded form, 5 to the exponent 6 is this. 5 to the exponent 2 is this. Now I'm dividing these powers. So if I have 5 and I'm dividing by 5, it cancels out. Every time I have a 5 and I divide by 5, it cancels out. So really what I'm left with is just this once I do all the canceling. So this simplifies to 5 to the exponent 4. Now what's the shortcut? Because I don't want to have to write this expanded form out all the time. Well, here's a 6, here's a 2. How do I use a 6 and a 2 to make a 4? I subtract them. 6 minus 2 is 4. So that's how you can simplify to a single power if you're dividing powers with the same base. Just subtract the exponents. Here's the more formal way of writing that. A power divided by another power with the same base. Reduce that to a single power, you subtract the exponents, m minus n, to get the new exponent. And now it's your turn. Try this. Simplify to a single power. All of these are dividing powers with the same base. So see if you can follow the rule and simplify these to a single power. Pause the video and try it. Here they are. 7 minus 3 is 4. So this reduces to a single power, 3 to the exponent 4. If the base is negative, the base is still negative. Just subtract the exponents. If your exponent is negative, follow the same rule. Subtract 15, subtract minus 1. Double minus, so it's 15 plus 1. Don't get tricked by that. Here, that minus sign is not part of the power. The power has a base of 2. 6 minus 3 is 3. So that minus sign is not included in the power, so don't write it like this. Write it like this. This is called a power of a power because the base of this power is itself a power. So this exponent of 2 means this gets multiplied by itself twice. So we have 5 to the exponent 3 times 5 to the exponent 3. Now I'm multiplying powers with the same base, so I can add those exponents, and I end up with 5 to the exponent 6 as a single power with one base with one exponent. Now what's the shortcut? How do I go from here directly to this? What do I do with the 3 and the 2 to make a 6? Multiply. So here's that rule. A power of a power gets simplified by multiplying the exponents. So now you try it. Simplify to a single power for each of these expressions. Use the rule, pause it, try it, see how you do. Here we go. Multiply the exponents. Keep the base the same. 7 times 3 is 21. 25 times 4 is 100. 15 times minus 1 is minus 15. 6 times 2 is 12. Remember that minus sign is not part of the power, so we write it like this, not like this. Now what if your exponent is 0? To show you how to evaluate that, I'm going to walk you through a pattern here. We know how to do 2 to the exponent 1, it's just 2. 2 to the exponent 2 is 4. 2 to the exponent 3 is 2 times 2 times 2, which is 8. And 2 to the exponent 4 is 2 times 2 times 2 times 2, which is 16. I can do all these. But how do I evaluate this? A lot of people will be tempted to write 0 as the answer here, but that's not what it is. So let's continue the pattern that we see here to figure out what the answer should be. So what's the pattern? Every time I reduce my exponent by 1, my answer gets divided by 2. Now if I kept that pattern going, what would be the answer here? 2 divided by 2 is 1. Okay, so 2 to the exponent 0 has an answer of 1. In fact, that's the rule. Any base with an exponent of 0 has an answer of 1. You can do this same activity for any base in a power, and you'll always get to an answer of 1 at this point. Whatever the base is, if the exponent is 0, your answer will always be 1. So here's some really challenging questions. I want you to evaluate these expressions. Get the answer. Pause the video and see if you can get the answer. Here it is. Any power with an exponent of 0 has an answer of 1. So why do I have -1 here? Well, just remember that negative sign is not part of the power. The power is 3 to the exponent 0, which is 1, but you have a negative sign in front of that 1. So that's why it's -1 there. Don't get tricked. Now, what if your exponent is negative? I'm going to go through that same activity that I just did. We're going to continue the pattern. And just to remind you what the pattern was, every time you reduce the exponent by 1, you divide your answer by 2, whatever the base is. So if I keep that pattern going, what do I get here? And what do I get here? Well, I get 2 to the -1 is equal to 1 over 2. 2 to the -2 is 1 over 4. Every time I divide by 2, I cut it in half. Now I want you to notice something. Compare 2 to the +1 to 2 to the -1. Look at the answers. 2, 1 over 2. Now compare 2 to the 2 to 2 to the -2. Look at their answers. 4, 1 over 4. The answers of the negative exponents are just the reciprocals of what the answer was for the positive exponent. Another way of writing that would be 2 to the -2 is the same as 1 over 2 to the +2, 1 over 4. 2 to the -4 is equal to 1 over 2 to the +4, would be 1 over 16. Now here's the general form. Any base with a negative exponent is equal to the reciprocal of that base with a positive exponent. So why don't you try to evaluate these expressions? To do that, rewrite the expression as a power with a positive exponent. Then evaluate. You'll probably get a fraction as your answer. So pause the video and try to evaluate these expressions. The reciprocal of 5 is 1 over 5. Change the exponent to be positive. 1 to the exponent 3 is 1. 5 to the exponent 3 is 125. Here the base is -4. The reciprocal is 1 over -4. Now the exponent becomes positive. Evaluate this. 1 to the exponent 2 is 1. -4 to the exponent 2 is positive 16. Here, don't get tricked. That negative sign is not part of the power. It's in front of the power. The base is 3, so the reciprocal is 1 over 3. The exponent becomes positive. We evaluate this. It's 1 over 81. But we have that negative sign in front, which makes this negative 1 over 81 as the final answer. Now, this is a negative exponent, so we're going to follow the same rule. We're going to change the exponent to become positive, and then we're going to evaluate. See if you can figure this out. So pause the video and try this on your own, and then I'll take it up when you're done. If you need help getting started, the reciprocal of 2/3 is 3 over 2. Try it now. Three to the exponent 3 is 27, and 2 to the exponent 3 is 8. So when I evaluate this expression, my answer is 27 over 8. For this last example, I want you to simplify, then evaluate. There's a few things going on here. We've got multiplying powers with the same base. We've got a power of a power. We have a division. You've got some negative exponents in there. Just simplify one piece at a time. Simplify the numerator. Simplify the denominator. Then simplify the numerator and denominator into a single power. If you have negative exponents, change them to positive exponents. Then evaluate. So pause the video and try to simplify this as much as you can. Then check back in. First, I simplified the numerator, so I add the exponents. The denominator is a power, so I multiply the exponents. Now I'm dividing powers with the same base, so I'm going to subtract the exponents. Remember, you're subtracting -6. So -8 minus -6 is -2. That double minus means you're adding. Don't get tricked. Okay, I've got a single power, but it has a negative exponent. So I'll rewrite it to be a power with a positive exponent. The reciprocal of the base is this. The exponent becomes positive. Now I have a single power with a positive exponent, and now I can evaluate that. 1 to the exponent 2 is 1, 3 to the exponent 2 is 9. So my final answer is 1/9. So we looked at multiplying powers with the same base, dividing powers with the same base, power of a power, 0 exponents, and negative exponents. And the last example was a combination of all those different laws. So you've got the exponent laws, you just need to be able to use them to evaluate expressions and simplify to a single power. There's lots of practice listed here. See how you do on it, and if you run into any issues, reach out for help.